If I'm asked to graph y equals 2 to the x, that's child's play at this point. I know it's going to go through 0, 1, and 1, 2. I certainly can make an x-y chart for that just to confirm what I've been thinking. -2, -1, 0, 1, 2. So y equals 2 to the -2. Well, I know that's 1 over 2 squared, which is 1/4. Y equals 2 to the -1, that's 1 over 2. Y equals 2 to the 0 is 1. Y equals 2 to the 1 is 2. Y equals 2 squared is 4. And I've got my xy points. A little more tricky is this one. If I have x and y is 2 to the -x, and I pick the same values, -2, watch what happens here. Y is equal to 2 to the -2, which is y, well, we know the opposite of a negative is positive. So this is 2 squared, or 4. -1, y is equal to 2 to the -1, or the opposite of -1, which is 1. 2 to the first is 2. 0 gives us y equals 2 to the -0. Well, there is no -0, so 2 to the 0 is simply 1. 1, y equals 2 to the -1. Well, that's 1 over 2. And 2, y equals 2 to the -2 is y equals 1 over 2 squared, or 1 over 4. When I graph these two functions together, here in blue we have exponential growth, y equals 2 to the x. And here, this down, scraping along almost this horizontal y equals 0, or x-axis, this is our exponential decay, y equals 2 to the -x. I simply graphed those 2 points that I named earlier. You can see they are mirror images over this y-axis. Again, exponential growth in blue, y equals 2 to the x. But y equals 2 to the -x gives us exponential decay. In both cases, no matter what I put in, as long as x is a real number, I'm going to get this y equals 0 line, which is the x-axis, as a horizontal axis. My y values will never touch this axis here. You might ask yourself, well, what's going on here with 2 to the -x? Well, let's examine what this means. This can be written as f of x equals 2 to the -1 to the x. Now, I know from my study of algebra that a to the m to the n is a to the mn, which means I can multiply this and get 2 to the -x. Oh boy, when I write it like this, 2 to the -1 to the x, I've not changed anything. That's quite legal. So if I write it like that, I can recognize that 2 to the -1 is 1/2 to the x. Notice, 2 to the -1, this exponent says I'm in the wrong place. So put me in the right place, which is down below. Now I'm happy. I was negative. Now I'm positive. Well, notice, this is f of x equals a to the x, where a is greater than 0, but a is not 1. So we're fine. But if we're thinking about what a can be on the number line, here is 0, and we can go this way, but we can't be 1. And we said if a is greater than 1, we have exponential growth, which I'm writing as EG. But if we have this area here between 0 and 1, if a is between 0 and 1, we have exponential decay. So this f of x equals 2 to the -x is really the same as x equals 1/2 to the x, which means exponential decay. I've already graphed this. Graph f of x equals 2 to the -x. But if we recognize that this is the same as f of x equals 1/2 to the x, we can then pick our magical points, x and y. If I say, well, x is -1, then I get y equals 1/2 to the -1, which is 1 to the -1 over 2 to the -1. Remember, this negative exponent just means I'm in the wrong place. If I'm above the division line, I should be below. If I'm below the division line, bring me up above. So this is 2 to the first over 1 to the first, which is 2. And 0 means y is equal to 1/2 to the 0, and I get 1 with that. So my two critical points here are -1, 2, and 0, 1. And I can draw my graph like that. Now, if you said, well, that's a lot to remember, to say, well, when it's an exponential decay, I want to choose negative values for my x, and when it's exponential growth, I'm going to choose 0 for x and positive values. Well, if you want to pick these two classic points, x equals 0 and x equals 1, then y equals 1/2 to the 1, which is simply 1/2. And we'd get this point here, 1, 1/2. And you say, okay, there is my graph. It's still going to be exponential decay no matter what. Notice what our exponential decay graph looks like. From left to right, it's going down, 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 and then it's hovering along this y equals 0 line, never touching it because there is our horizontal asymptote. How about these two? Y equals 4 to the x. Well, I can tell you that's exponential growth. It's going to go through 0, 1, that magical point, and let's see, if x is 1, y is 4, so 1, 4. How about this one? Well, this is the same as f of x equals 1/4 to the x. So I know this is going to go through this magical point 0, 1. If I put a -1 in, I'm going to get 4. So if I'm graphing these two, they're going to be mirror images of each other over this y-axis. And of course, they're both going to go through this juicy point, which is 0, 1, and this is the exponential growth, 4 to the x, so it's going to be 1, 4. And so this blue graph is y equals 4 to the x. Now this red graph is going to go through 0, 1. If I put in a 1, I'm going to get 1/4, so this point here. But I personally like this -1, 4 point because it gives me some nice symmetry here, and it's going to look just like this. This is y equals 1/4 to the x, also known as y equals 4 to the -x. You've got to be able to recognize this is the equivalent of this. Notice our base is actually between 0 and 1, so it's exponential decay. And we've got this beautiful y equals 0 horizontal asymptote in each case. Notice they are mirror images of each other over this y-axis.